So we might be thinking, what is the power source which is present in the satellites? Now, how satellites generate their power by themselves? It's an important question because if they have to survive, they require some electrical energy, and how that electrical energy is generated in the satellites. Most of the satellites use the solar panels to generate the power, and the generated electrical energy is stored in the batteries. Now, what can be the different types of batteries which are used in satellites? Now, if you look on to the space battery system, the battery should be in such a way that it lasts long, because if the battery fails, the entire machine will be failed. So the life of the battery is very important, and the type of batteries which we'll be using on the satellite should have some parameters. That means if you see the energy density of the batteries, energy density means the energy stored per unit mass. How much energy is stored per unit mass? Now, that is an important parameter for the batteries which we choose for satellites. And mostly the type of batteries which we'll be using in the satellites are nickel cadmium, nickel hydrogen, nickel metal hydride, lithium ion, lithium polymer batteries, and silver zinc batteries are used in the satellites. So most of the satellites. And if you see the energy density of all these batteries, we can see that nickel cadmium batteries have very low energy density. And relatively, nickel hydrogen batteries are better than the nickel cadmium batteries. And nickel metal hydride batteries are better than nickel hydrogen, and lithium ion batteries are better than all the other batteries. Lithium ion or lithium polymer batteries are used mostly. So, if you see the energy density of all these batteries, we can come to a conclusion that lithium ion batteries or lithium polymer batteries are better than all the other batteries used in the satellites. And nickel cadmium batteries are the batteries which were used in the satellites at the early stage. But today's satellites mostly use lithium ion or lithium polymer batteries. And if you see the cycle life performance, cycle life means here the one cycle is considered to be one full charge and discharge. It is considered to be the one cycle. That means if we charge battery to full, how much and by the time the full charge gets discharged, this complete process is termed to be one cycle. And the cycle life of the battery is very important in the batteries. Now, if you observe all these batteries, the cycle life of the batteries, nickel hydrogen batteries have more cycles than any other batteries. That means the lifespan of the nickel hydrogen batteries are more than the other batteries. And lithium ion batteries have 10k cycles we have, and if it is nickel hydrogen we have 40k cycles. So based on these performances, we can choose that either nickel hydrogen batteries or lithium ion batteries can be used in the satellites. Now, if you see the different types of batteries which are used in the satellites, so earlier we were having nickel cadmium batteries. The cycle life of the nickel cadmium batteries are 2000 to 5000 cycles. And we can see that memory effect is present in the nickel cadmium batteries, which is not present in the which is relatively lesser in other batteries than the nickel cadmium batteries. And if you see the nickel hydrogen batteries, the cycle life of the batteries is 20,000 to 40,000 cycles, and these are better than the nickel cadmium batteries. So we can choose nickel hydrogen batteries than the nickel cadmium batteries. And if you see the lithium ion batteries or lithium polymer batteries, these have better life cycles. If you see the cycle life of lithium ion batteries, we have 5,000 to 10,000 cycles, and the energy density of lithium ion batteries is 150 to 200 watt hour per kg we have. And similarly, if the lithium polymer batteries we have, it also has the same density, almost equal to same density, and lifespan of the batteries is also almost same as the lithium ion batteries we have. So the batteries play very important role in the satellites. We can see that how energy density is calculated here in this expression. Energy density is calculated by battery capacity by battery mass. And for example, if we have a lithium ion battery which can store 200 watt hour of energy and weighs 1 kg, then energy density is said to be 200 by 1. And similarly, nickel cadmium batteries energy density is 40 watt hour per kg. And cycle life we can see here, the total number of complete charge discharge cycles of a battery can undergo before its capacity drops below certain percentage. And the main factors which we'll be observing in the batteries which are used in the satellites are depth of discharge. Deeper discharges shortens life, and the temperature also. If you observe the temperatures in the space, they may range from minus 150 to plus 150 degree centigrade. So the battery should be constructed in such a way that it has to cope with these operating temperatures. And charge discharge rate is another factor which will decide the quality of a battery. And the type of chemicals which we use is also plays a very important role in the batteries.